Mac 1105, Chapter 1, Section 5, Solving Inequalities. All right. First thing we have to be concerned about is to make sure that you, at some point in time in your mathematical career, you've been taught that if you use an open point, now we're going to use parentheses when we have interval notation. Open point in parentheses also indicates less than or greater than. We have a closed point, we use brackets. Closed point or brackets indicate less than or equal to or greater than or equal to. In your textbook on page 120 is an excellent chart which shows you all the possibilities that inequalities can have. This is a chart that you're going to hopefully make reference to the whole course. You can see that whenever we have infinity, whether it's negative infinity, which is on the left, or we have a positive infinity, which is on the right, anytime we have an infinity sign, we use parentheses, never a bracket. Parentheses indicates that we're going to a value, but we're never going to reach that value. Going to some example problems. This is example 7 in section 5, chapter 1. It says 3 minus 2x less than 5. Well, first of all, in order to solve algebraic problems, we're always trying to get multi-step problems to two-step form. Two-step form tells us that the variable numbers in the front, added or subtracted to a constant, less than, greater than, less than or equal to, greater than or equal to, or even equal to a constant. So what I did here was I just rearranged it. I moved the negative 2x out in front, the positive 3 out to the back. So this 3 minus 2x less than 5 is the same thing as negative 2x plus 3 less than 5. No sign in front means a positive. That's the reason it's a plus. Now I'm in two-step form. If you look at this, my two steps are subtract the 3 over, divide by the negative 2. I always want it in two-step form because not only does it tell me the two steps I have to use to solve it, but also if I look at the number with the variable, if it's negative, when I'm solving an inequality, that tells me I'm going to have to flip the sign. So what happens here is I subtract the 3 over, 5 minus 3 gives me 2, still a less than, so now I'm at negative 2x less than 2. If I divide both sides by a negative 2, I get a negative 1, but I have to flip the less than to greater than. So here's my algebraic notation. X is greater than negative 1. Now your inequality always helps you in terms of your graph, because the inequality always points in the direction you shade, so we're shading to the right. Because it's a greater than, we can see we're going to use parentheses. Because we're going to the right, the parentheses opens to the right. Whenever you're doing a graph for me, you got to always indicate 0. So 0 is always going to be on your graph. Put my negative 1 to the left where it's at, parentheses, shading to the right. Now if x is greater than negative 1, this is saying x is greater than negative 1 too. As far as the interval notation goes, I just copy the graph. Come from the left. What I first hit is parentheses negative 1. Where am I going to? Positive infinity. We already said that infinity is always a parentheses. Now, when you're solving these problems for me, in this chapter 1, in sections 5 and 6, when we have the test, your answers must have all three notations. You must have the algebraic notation, the graphical notation, and the interval notation. All three of these answers must be present if you want to get credit. If any one of them is missing, I will mark the whole problem wrong. Went over here to example 8. It says 4x plus 7 greater than or equal to 2x minus 3. Again, we're going to get in two-step form. So the first thing I'm going to do is I'm going to subtract this 2x over from 4x. It's going to be 2x plus 7 greater than or equal to negative 3. Now I'm in two-step form. I've circled it in red to indicate to you that I'm in two-step form. So this tells me subtract 7, divide by 2. I don't have to flip the sign. Subtract the 7, I get 2x greater than or equal to negative 4. Divide by 2, I get x is greater than or equal to negative 2. Greater than or equal to is a bracket. Starting at negative 2, there's my 0. Telling me to shade to the right. I do my interval notation. Coming from the left, first thing I hit is the bracket, negative 2. Where am I going? Positive infinity, parentheses. This is example problem 10. And notice this is a different notation. This is actually a compound inequality. And the reason it's compound is because we have two inequalities in one. It says negative 1 less than or equal to 3 minus 5x over 2 less than or equal to 9. Whenever you have a compound inequality, it's always written in terms of less than or equal to. Never greater than or equal to. Because graphs are always read coming from the left, going to the right. So they're always read by the lesser value going to the greater value. First thing I do here is I switch these around just like I did in example 7. Instead of writing it as 3 minus 5x, I write it as negative 5x plus 3 over 2. And I multiply both sides by 2. Get negative 2 less than or equal to negative 5x plus 3 less than or equal to 8. Notice I'm in two-step form. Subtract 3 from both sides. I get negative 5 less than or equal to negative 5x less than or equal to 15. Divide by negative 5. Remember, if I divide by a negative, I got to flip the sign. So this now becomes negative 1 greater than or equal to x, which is greater than or equal to negative 3. Negative 3 is a smaller value than negative 1, so when I take these two values and switch them, I've also got to flip the signs. So when I move the negative 3 over here and the negative 1 over here, I've got to flip this greater than or equal to, less than or equal to, less than or equal to. Now I'm in correct algebraic notation. Going from my lesser value to my greater value. So it says negative 3 is less than or equal to x, which is less than or equal to negative 1. This is how I do my graph. Coming from the left, first thing I hit is bracket negative 3. Keep going until bracket negative 1. My interval notation is exactly what the graph is. Bracket negative 3, comma, negative 1, bracket. So make sure you understand that when you do a problem for me, homework and on a test, I want all three notations. I want algebraic, I want graphical, and I want interval. If you do not have one of the three, I will mark your problem wrong.